In this video, we will talk about how part of the mass of matter is transformed into binding energy in the nucleus of atoms. First, I will try to formulate the original idea of the essence of nuclear force more clearly. And then, I will tell you another, more logical version. In the theory of moving space, the connection between protons and neutrons in the nuclei of atoms is carried out as follows. When approaching a nucleon, space accelerates tens of millions of times per second. And if you remember, acceleration has an inverse square dependence on distance, and as you get closer, it increases quadratically. And in the immediate vicinity of the nucleon, this acceleration is maximal. And this sharp increase in acceleration leads to a sharp increase in the force of inertia, which becomes stronger than the repulsive force of the Coulomb. But as we remember, the main problem is that the force of nucleon repulsion also has an inverse square dependence. But at the same time, this force is many orders of magnitude stronger than the force of gravity. And this fact was the main reason for searching for an alternative force that would explain the bonding of nucleons in the nuclei of atoms. And it was necessary to assume the existence of nuclear force. We are still dealing with the consequences of this to this day, in the form of problems and paradoxes associated with neutrinos, and not only. So we have two similar dependences of forces on distance. And based on this dependence, at any distance, the repulsive force is many orders of magnitude greater than the force of gravity. But this comes from the fact that we assume that the force of gravity or inertia increases proportionally to the acceleration of space. But what if this force that arises with such a sharp increase in acceleration does not increase in proportion to the acceleration? What if it grows exponentially, like the growth of relativistic mass? What if there is some acceleration threshold after which the inertial force starts to increase faster? And what if we don't know about it, because humanity hasn't even come close to the threshold yet to notice this nonlinear growth? Or maybe such accelerations were achieved, but the effect itself remained unnoticed? However, whether this is true or not is not important, because there is another version of the explanation of nuclear force, which intuitively suggested itself from the very beginning. This version is simple and logical, and much better connects nuclear force with mass defect. Remember what determines the mass of matter in the theory of moving space. The mass of matter is determined by the fact that space moves with acceleration towards each nucleon and enters it. By this movement, each nucleon is connected with space. And the mass of a nucleon is determined by the amount of space entering it per unit of time. At the same time, one of the important conditions for space to accelerate when the flow narrows is the incompressibility of space. Incompressibility or inelasticity. At the same time, matter, despite all its apparent integrity, is in fact 99.9% empty space, permeated with electron clouds and electromagnetic fields, and therefore it is almost transparent to space. Space moving towards a nucleon passes unhindered through all matter, and the only opaque or partially opaque for it are other nucleons. And in conditions when nucleons in the nucleus of an atom are located very close to each other, the space that moves into the nucleon, due to its inelasticity, is not able to bend around neighboring nucleons, or it can bend around, but due to the very small distance between the nucleons, the flow of space is not completely restored. As a result, a smaller amount of space enters the nucleon per unit time, and this means that its mass becomes smaller. In turn, it is logical to assume that if the flow of space decreases from any side, then the nucleon accelerates in this direction. This is how the acceleration of this nucleon in the direction of the neighboring nucleon occurs. The occurrence of this acceleration can be explained, for example, like this. If we imagine that a nucleon sucks space into itself, and from the side where the speed of space is less, some semblance of a vacuum arises, which carries the nucleon in this direction. A similar situation occurs with neighboring nucleons, and thus the nucleons in the nucleus stick to each other in quotes. And the more nucleons are concentrated nearby, the larger the mass defect and the specific binding energy. But with the increase in their number, some saturation occurs, in which each new nucleon does not make a large contribution to the specific binding energy. since it is located far enough from the majority of nucleons and does not create a serious obstacle to the flow of space to them. And here, the incompressibility or inelasticity of space could potentially provide an explanation for why the nuclear force is superior to the Coulomb repulsive force. And the effect of nuclear force only at short distances is explained by the fact that the flow of space at a certain distance is completely restored. If you try to find an explanation of how the mass of nucleons is converted into binding energy, you will not find an answer. There's a formula for calculation. There's a general understanding that mass is materialized energy, but there is no explanation of how mass is transformed into binding energy. And the described mechanism of nucleon movement in the direction from which the speed of space is lower can give a hint as to why acceleration of matter occurs in accelerating space. But about this some other time.